We are finishing this chapter, and this is the chapter, the last chapter that forms part of the test. So this is the end of chapter 3. Where do we start? We've done the Zener diode. We have seen we've seen that the Zener diode works in forward bias. There we get the voltage of the Zener, and the reverse bias we get 0.7. We've also done an example. Now here's another example. This circuit, I've got a 24 volt input, and I was asked from the minimum, the IZK, I must determine V out. For the maximum IZM, I must determine the output voltage. I must calculate the value of this resistor, and then I must calculate the minimum value that we can have for this resistor. Where do we start? I start by looking at the Zener, and I see there's no VZ voltage given. Therefore, I know if I see a number, I know I must use a data sheet. And this is now 1N4744A. Therefore, I must go look on the data sheet and write down all the information as I showed you on the previous Zoom session. VZ 15 volt at IZ 17 milliamps, IZK 0.25 milliamps, ZZ 14 ohm. The power dissipated is 1 watt. And you can immediately do this calculation because you always need to know what IZM is. So you can immediately do PD over VZ, 1 over 15, and get your IZ maximum, the maximum voltage of your reverse bias Zenith. Right, now, let's start. My V out for the minimum IZK. I have my formula, VZ minus delta IZZZ. Now, delta IZ is the difference between my IZ and my IZK. So it's IZ minus IZK times 14 the ZZ given. And I get a voltage. Now for my maximum voltage, my output will be VZ plus the difference in IZ. Where the difference in IZ now will be my IZ maximum plus my IZ. Then I get the voltage. So now my first two have been completed. I have calculated the V out. Now I must calculate R, the R value. And I say V in minus V out over IZ maximum. And in the example in the book, there's a mistake. So if you don't check the Zoom session, you will not pick up the mistake. So it's your 24 minus your 15.65 over your 66.667 milliamps, and you get 124.569. But they ask here, what is the nearest available value? Now, we are working with the E12 range. We've done this in the first notes that we did, the first lesson or two. We've done the nearest available value. The nearest available value for 124 ohms is 120 ohms. So now I change it to 120 ohms. Now I must determine minimum. So for my mean current, I can determine my I total is my VZ minus V in minus V out over R. Therefore, your 24 minus your 14.766, that one, and over your R1, your 120 ohms, the nearest available value, and you get your answer, and you have a current. a total current. Then your current through the load is your total current minus your neat current, and then you have the current through the load. Now, if you have the current through the load, you can determine the minimum. It's V out over IL. It's 14,766 over this current, and you get a number of 1925. 1925. 1K925. I lied. 192,56. I can't even read my own writing now. I must you read it. 192,516. Right. What's the nearest available value? 180 is the one. And then there's 10 ohms. Because there's not 190, there's no 200 kilo ohm or ohm. You get 180 and a 10 ohm, then you end up with 190 ohms. And that's the nearest value you can have for your minimum load resistance. And now, this is the same as the diode clipping circuits. Pinpoint and focus on one point. For your Zener, it's a little bit different. I try to use the same method to get to the answer. If your Zener, this is your input, this is your output. If the negative side, your cathode, is on top, I look and I see when my diode is forward biased, my Zener diode, if it is reverse biased. If it is reverse biased, I get 0.7. What 0.7? Because the cathode is here, I get minus 0.7. And if there's with the reverse, with the forward bias, it's 0.7 minus. The reverse bias must be plus Vz. So, in this case, I have the anode here. So I will have a plus 0.7. And if I have a plus 0.7, I will have a minus Vz. Yeah. Let's go back. Minus 0.7 plus Vz. Minus 0.7, which means my negative side will cut off at minus 0.7. My positive side will cut off at plus Vz. Plus 0.7, my positive side will cut off at plus 0.7. My minus Vz means my negative side will cut off at minus Vz. But now, just like the two diodes back to back, I put two Zeners back to back. What do I get? I get minus 0.7 plus Vz plus 0.7 minus Vz. How does it work? Because why do I need the two? If the one Zener is forward biased to give me minus 0.7, the other one will be reverse biased to give me minus Vz. And that is why I've got this little cross. This cross to there, that cross to there. If you know, this diode will give me minus 0.7 plus Vz plus 0.7 minus Vz. You can do your cross connection and your output will be minus 0.7 minus Vz and plus Vz plus 0.7. And you can draw it. Plus Vz plus 0.7 minus Vz minus 0.7. And that is the easiest way to remember clipping for Zener diodes. Because the forward and reverse bias is different than a diode. That is where normally everybody goes wrong. The forward bias part is exactly the same as a diode. Therefore, I start with the forward bias part. If my Zener diode, if it is forward bias, I see there's the forward bias, the anode plus 0.7. This one 7, this one plus 0.7. Always with reference to this point, with reference to this point, with reference to that point. Just like with the diode, you pick one point as a reference and you determine what you will be, what you will get. And if you get 0.7 forward bias negative, you will have plus VZ. If you have plus 0.7 forward bias, you will have negative VZ reverse bias. So that is as easy as it is. This is typical questions that you can ask in the test. You're writing test on Friday. I will put the scope on the test as well as the fact that you need a data sheet for your Zener data sheet as well as your formula sheet. Both are available on Blackboard. Make sure you have it when you write the test. I will put it on the group and I will have Hanlie put it on Blackboard as well. And that is chapter 3 from me. Until next week, bye.